Welcome to the Industrial Data Science panel. Hope you had a great show so far. We had a couple of great talks today. Taposh and Nahum just coming off talks, Xavier in the morning.
6+1.
And so some of you are known, but I'll probably go a quick round of intros. Nahum is just hot off press, so he can, when he's known to the audience.
Intro?
Yeah, just a second.
I'm with PayPal. Recently, new independent public company. Prior to that, I was with eBay, as known as Marketplaces. And I've been running machine learning, data science through my tenure in both companies with very large data sets. What?
Louder.
Oh, this is not working?
It's on, louder.
Oh, okay. Louder. This is the first time someone tell me to talk louder. So basically, I have experience in very large data sets. In eBay and PayPal, we have multi-petabytes. And both the system that work with them and how you prepare the data and how you take and build models on them. Prior to that, I had my company, which I co-founded. They did model for B2B pricing. And prior to that, I was with SRI International, building the internet. And so this is basically my 2 cents worth.
Okay, so I'm Xavier Amatriain, and I'm VP of Engineering at Quora. And my background, so it's interesting because I get called to a lot of talks and conferences and panels about data science. I've never been part of a data science team or led a data science team. I've always sort of like been more on the engineering side of things. But my background is academic, so I have a PhD and I was in academia.
I thought if you're drinking water from Barcelona, you become a data scientist.
I'm from Barcelona and a big Barca fan. So I've been doing a lot of data machine learning, and my background is there. But I think I'm kind of like navigating in the sort of like this blurry line between data science and engineering. Previously to being at Quora, I was at Netflix and I was leading the team building the recommendation engines and systems, and we work with Sri and H2O in several projects there. And again, I was involved both on the data machine learning side of things as well as making these algorithms scalable and making them work in production.
Thank you. Sri with H2O.
That's modest, very modest, Sri. So I'm Taposh Roy. I am with Kaiser Permanante. Kaiser Permanante, for people who don't know, is an integrated healthcare system. We are one of the largest integrated healthcare system, and we have around 10 million members. About my background, before joining Kaiser, I was working on ad tech. I was working in several startups. I have, during my graduate time, school time, I did work in cellular Monte Carlo simulations. So my background has always been playing with data. I have worked with financial industries. I have worked with healthcare. Now I'm working with it. And so it's been a tremendous learning for me in healthcare. And I felt that this is the best place that we can impact life and use data for it. It's my 2 cents.
Great. My name is Da-Ching Zhao. I'm with Macy's and the department store, and I lead the advanced analytics teams. So we have a predictive analytics team that build models and build scalable, and a lot of models. And we also have a team that's more data science that does some of the development for real-time scoring and recommendations. We also support test experimentation. And so I see myself more on the science side, and we use a lot of data, but our goal is to find relevance for our customers and optimize our business processes. And before Macy's, I worked with a number of ad tech or internet companies. And before that, I worked for Bank of America, working on risk management systems. And originally, I had a PhD in science and bioinformatics, physical chemistry. And so, but always in my life, I use computers to process data, to do simulations. So Monte Carlo is a very familiar word. And so I really, love that with the expansion of computer technology, we're able to solve more and more important and more interesting problems.
Awesome. Thank you for coming.
I'm Scott Marsh. I work for Progressive Insurance in our personal lines auto pricing organization as a research and development manager. I think I got into data science probably over a dozen years ago. My school offered statistical courses in R long before R was a popular language to be programming in. So my lineage with data science goes back a long ways. After school, I started working for Progressive and started studying for actuarial exams. And at some point along the way, I got distracted by predictive models.
So if you're from Cleveland, you're very likely to be a data scientist as well, much like Barcelona? Or?
Yeah, well, we have quite a few people here attending the conference from Progressive, and I think we have a pretty good contingent of data scientists. I think the Cleveland market is definitely heating up in terms of both big data and data science. I think I started going to Hadoop users groups 4 years ago when there was like 11 people in a conference room huddled around some pizza. And I think our high water mark for our Hadoop user group recently was like 600. So I think it's taken off in Cleveland.
Awesome. So without further ado, we'll jump in. We'll probably do a quick quiz, actually. What's your favorite algorithm? Quick, 1 second.
I only get one algorithm.
Yes.
I'd say a gradient boosted machine, probably.
I would say ensemble, because that's a trick one.
Oh, that's like asking the genie, can I get 10 more wishes?
Okay, 1, 2, 3, maybe.
I would say a first start, probably a random forest. Relatively little tuning to be done and gives you a pretty decent benchmark.
Yeah, for me, I think I would rank GBM as the first one. And of course, I'm a big fan of deep learning and the potential that it has. And finally, of course, the best thing is to do an ensemble. I mean, that's the best silver bullet that helps.
I like locally linear embedding, but what about you?
So just to be a little bit contrarian, if I get to pick one, I'll pick the simplest. So I'll stick with logistic regression, maybe elastic nets, adding L1 and L2 regularization. That's a good way to start. And then I'll
The most
make it
widely sold algorithm of H2O is L1, L2 regularization,
Yeah.
lasso. So next only to GBM.
Yeah, I like the ones I tried a lot. The ones that they found good results were basically GBM, random forest. And so I like those who deliver the results. But then be open, try them all.
Yep.
I think the key is to try more, to test for a particular problem. Actually,
Right.
some algorithms are better than others, and so in that sense, I'm agnostic as long as it works.
All right, now with that out of the way, what is your favorite munging tool?
Munging tool, now or what will be in the future? In the future, it will be H2O munging facility.
All right.
But since I haven't tried it
This
yet,
one nice.
I don't know. But I'm pretty either Python or R. Like in one of the big projects that I've done, I did analysis using R that is deployed on 1,000 node Hadoop. And I ran MapReduce using R and streaming, but I used the maps the maps in Python because they analyze text, etc. And I like much better Python to analyze text than R. But later, when you got the data frame and you want to run the model on them, then I use R. So this is kind of the nice thing. You take Python and then you supplement with R and you get a result. So that's basically as before, whatever works.
Oved.
So as opposed to the algorithm, for me, it's very hard to pick one tool because I don't think there is a tool that solves everything that I need. So that's a big problem. If I had to pick one that kind of integrates at least on the user-facing front, I would go for IPython notebooks, which I think you can then connect on the background to Spark and to Scala, but also Python. So I think at least on that sense, it's sort of like a good entry point for solving several kinds of problems. But then for sort of like the production side of things, you need to sometimes get as low as C++ or making things in custom map-reduced jobs. So it's hard to pick one single thing that
You've done that. You have done custom map-reduced
Yep.
code for munching and cleaning all
Yep.
the time, I would imagine. Awk. Awk is a good one.
Awk is an awesome one.
That's great.
For me, I think I agree with Nahum on the Python. Python is like a silver bullet in many things. Of course, when you productionalize, for me, I would prefer Java. It's faster in that sense. But if a user wants to play with things, I would say IPython notebook is the simplest and the easiest to play with.
Yes, I agree, and there's so many tools, and sometimes one is more convenient than others, and I've used even MySQL and put some indexes on there, and you can slice and dice, and
SQL is a common tool.
Yeah, and for really big data, then we have to use Hive, and we definitely look forward to using Spark and H2O, and so that we can get answers much faster. And in the past, I've even used SAS. Data steps and ProdSQL are quite convenient. But we are embracing or testing new concepts, new platforms, so that we can increase our throughputs.
I like set and awk. No, I think if it fits on a single machine, I like data table. Matt Dallas done some great work. It's incredibly fast. If it's larger, I like Hive.
Not PlayR, just data table.
Data table.
You're in the right conference.
Yep.
Awesome. How many of you are Python versus R versus SAS? Is there a poll? Do you see it more often in your companies? Is there a shift from R to Python? Is there a shift from SAS to R?
Well, I would say it's kind of all of the above. It depends on where you are in the organization. For me, I'm a big R user, but other areas of the company use SAS. People use Hive. It's kind of all of the above. There's no dictated tools, I don't think.
I would say at Macy's, it's a very similar situation. Traditionally, we have R, we have, or even Oracle, and in Macy's.com, we have a big Hadoop cluster that we put all the data in there, and pretty much depends on who the data scientists are, and we don't try to force someone who is comfortable with R and teach them SAS or vice versa, and but we are very glad seeing that actually everything is converging, and it almost doesn't matter, and we have these flows and all that, and so I think more and more we want to focus on the science rather than the particular flavor of some tool.
So I agree with you 100%. If somebody is skilled in SAS or somebody is skilled in Python, they should have the flexibility to do that. I think the end results matter. The tool doesn't. But yeah, I understand sometimes organizations need to have one over the other. But I personally believe that if you have the skill to do something really fast in the language you know the best, do it, and we can take it to the next level and think about productionalizing it.
Quora has no SAS, right?
No, actually, I was going to say, I'm going to disagree with the previous answers to this question. And my point is, like, if you have a big organization with maybe 50 or 100 or I don't know how many data scientists, you can tolerate sort of like having different tools and having different subgroups using different tools. But as a representing kind of like the startup world, when you have 15 data scientists and you want to maximize the speed of how that can quickly go into production, and you don't want to have sort of like long delivery times, and you want to iterate quickly and fast, I honestly think that there are some tools that are better than others, at least until somebody proves me wrong and sort of like integrate them in a way that can be used more easily in the innovation cycle. So at Quora, there is no R. So nobody uses R. I mean, a lot of people know R, of course, and the data scientists, they might use it, in their free time. But most of the things they do is actually Python. And the reason is the actual production infrastructure is a combination of Python and C++ already. So if you do something in Python, you're almost halfway there. So you're going to be much closer to integrating into production than if you are in the R world. As a matter of fact, in Netflix, where I was before, there was already a trend for data scientists to move from R into Python for a similar reason, and also the fact that it's easier to integrate with IPython notebooks, and then that gets you into Spark and so on. So I would say, at least in the small startup world, there is a trend sort of like towards more Python and less R, but maybe it's my own bias.
We've seen that in Tesla, we've seen that in Lyft to a degree as well. And I'm curious to see what you have to say.
My opinion is it depends on the stage at which you are doing the work. Sometimes you just want to think and write and try all kind of things. I find it easiest for me to do it in R. Just go and sit and get data and try it and get some charts and see what it is. Once you establish what is that you want, then you need to think, I agree, you need to think about production. I have yet to see, although I heard that some company put R in production, I have yet to see a company that talks about R in production in first-person singular. And yes, I don't have a concrete example. But the point is that if you go beyond the proof of concept, beyond the exploration, and actually get it to the hands, to the field, either in, as I said, like in batch, for people to pull the results and to use, or you want to do it in real time through API, through REST API, then you need to think about the language that will let you do that efficiently and fast and smoothly. Yeah. And at that time, you need to be flexible enough to take the algorithms and put them in Python. Luckily, it's not that hard to take what you've done in R and to translate into Python. You have the packages to do that. So it's not that far apart. So if you are familiar with both of them, and if you decide to go in production, go in something that is production ready.
Although I think that having used R before and sort of like moving more into the IPython notebook world, I find it right now is like if you have a couple of IPython notebooks that you can start working with because they've already been set up in some way and connected to your data sources, and you connect to using things like scikit-learn, pandas, and things like that. It's so easy also. It's very interactive. So I don't see much of a difference right now between Python and R if you use the right tools. Maybe, I don't know if they're...
So code reuse is an interesting aspect.
I agree, although to me, doing R on Emacs is the highest productivity ever.
How many of you use R on Emacs?
On Emacs?
The audience.
Emacs.
There's a few.
Yes. Because in the history, I used Emacs for so long. Here you have R on Emacs. Real data scientists.
How many just a show of hands, how many have Python users in the audience?
Oh, yeah, that's it.
Yes.
Yeah, let's be nice to Python.
I think there's no question as Python have more and more functionality development and also familiarity. I think it depends on the experience and the past experience. If I've done something in SAS, I can do that in a few lines.
Yes,
absolutely.
absolutely.
And especially in exploring this, you explore so much. In the end, you decide, and during that exploration phase, you can do anything you want.
Python is actually, one of the few, I would say, truly open source movements, right? There was no company backing Python for a long, long time. And they still emerged despite other languages being pushed by big companies. So Python is, I have true respect for their open source commitment and movement.
And IPython coming up has actually really bring Python back into the limelight.
So Scikit versus Pandas, do you write your own, or do you adhere to any of these packages, or you write your own packages?
All of, we
use all of them.
We use all of them and combine them in different ways or form. That's the great thing of the open source Python ecosystem, right? You can just connect to Theano or Scikit-learn, or there's a bunch of deep learning tools that you can also connect to, and you do that from the same IPython notebook. So it's you integrate all of those. It's very similar to R in the same sense that you get a bunch of R packages and you can just use them from the same interface and the same Emacs.
Emacs is good because it can work, and with R you can just run one line, a long line, which is a whole program, is one inside the other. That's cool, and I agree. IPython is great if you want to share data to collaborate.
Yeah, exactly.
I just recently got my hands on PyCharm, which is a very good tool to build projects. If you want to build projects similar to Eclipse, etc., the same idea, and or IntelliJ, the same thing. So if you want to build a project, you go on PyCharm. If you want to go and share and do collaboration, IPython is great.
That's a good point. The sharing element of sort of like having a tool that you can easily share among different teams.
Absolutely.
How many of you use version control systems for sharing your scripts?
Which one?
Version control for sharing your data science.
GitHub.
Everything.
Everybody's GitHub.
Everything on GitHub.
We're not as, sophisticated in that sense.
Yeah. We have internal GitHub where
but certain projects
Hadoop jobs, all of the Hadoop scripts and jobs, you write and put them all into it.
Absolutely.
VCS.
Everything needs to fit, and we have it internal, so it's secure, etc. You don't.
So we use Stash in addition to, depends. Basically, Stash is also Git fork, basically. So Stash is very common. So Kaiser, we use Stash.
What are, now jumping slightly into the elements of data, right? When data science starts with data. How hard is it in your organizations to get data?
Start with me. I think Progressive's had a long lineage of being a very data-centric company. Peter Lewis really founded a company around data. Used to say that we're a data company that happens to write auto insurance. So I think we have a really long lineage with data. I think we're modernizing everywhere. I think we're really converging around a more centralized enterprise model. But I would say that data is plentiful. I think you more have to know what you want to look for than not having access to it.
Is that true for PayPal as well, I would imagine?
You can get data from all over the map. It's very data-aware company. And to me, the challenge is to understand, because the data exists in multiple versions. Someone takes this table and creates another table based on the other. It's basically what's the lineage of the data, where it came from. Another thing that I find, and this is a constant struggle, is the data dictionaries. What every columns mean, especially in business, and if you have like categorical variable with all of these symbols, what do they mean? And so in order to actually use it, you need to understand what's in those columns, what in all these features. And this is something you need to go and find what the source is. PayPal is doing great things in that. But
how do you catalog data today? I mean, you have
What's that?
probably data repositories of different.
You have data repository, you have data dictionary, you have schema that you can go and run, but is it fully documented? Is every one of them, like you have a metric, they will give you an example, this is how this particular business metric is calculated, etc. To say that this is 100% will be somewhat of exaggeration. But you have to go to see who is using it, and this is part of the legwork that you need to do.
Yeah. I would second that. I mean, I'm sure we would be amazed of the millions of dollars that are being wasted by data companies right now in the feature engineering step by basically redoing the same thing over and over again by different people in different teams. Even small companies, it already happens, right? It's like people are using the same data with different meanings and defined in a slightly different Hive query that is not well documented, and putting that into a common dictionary or catalog and making sure that different people in different teams reuse what is being done. I think it's, I mean, I don't know if anyone has the silver bullet, but I think every company that I talk to is an unsolved challenge is how to get that.
It's almost like you may need version control for data catalogs itself.
Yeah, I mean, there's a ton of things have been done to solve similar issues on the software world, and there's patterns, there's tools that, there's version control, there's many things that sort of like help you reuse the same concept and the same implementation over and over again. In the data world, that barely exists, and we need to just make it up and invent it. Everyone tries to invent their own thing, and it kind of works somewhat.
Yeah, no, that makes sense. I mean, having a good ontology system definitely helps, because then the lineage and the cataloging and the taxonomy of it, that really brings it all together. I've not seen many companies using ontologies. We are researching into ontologies right now, but to get everything in a way that's easy for people to get in. Yeah. I think that's where this thing will mature too, towards the end.
Yeah, so just a comment on this. There are quite a few startups
yeah.
that will promise to do all of it. So instead of sifting through the data,
right.
enough sift through all the offering of all the companies to see which one will be best.
Yeah.
You shift the effort.
Shift the effort to find the right one.
But there are quite a few of them that are now promised to provide a comprehensive solution on this, and big data, and make sure that they will go around and will tell you lineage and all of this kind of stuff.
Yeah. And Macy's, I think we have a lot of data. A lot of data are centralized, and they're enough for us to analyze. Of course, there are always more data to be collected. There are always more data to be analyzed, and a lot of time we find that our team, analyze more data. In the end, they become the experts in understanding those fields or a particular type of data, and then they help the rest of the organization. Of course, we have vendors as well, but vendors tend to be more on the how to scalable, that type of thing. We found that we really need the internal expertise so that really understand, how the data is collected, what are the distributions, how to be used, and what are the pitfalls, because nothing is perfect. And, we balance, between quality and coverage, and that's a never ending. And I tell people, data is never clean, but of course it's never completely, well, unless you really had bad trouble, and never completely useless, somewhere in between. And we have to make that judgment, is the data good enough for us to make this type of decision? And we have to go from there. If it's not good enough, let's improve it. If it's good enough, let's not spend all the time improving the data without generating the marginal returns.
In terms of data science, what kind of problems are you solving? Just recommendations?
Macy's, it's a range of problems. We can say also a portfolio of problems. At the beginning, if we just collect the data, we just want to explore it and see how is the data, and generate some insights, make some presentations. Maybe data can be improved. Maybe there's some low-hanging fruits, and our business managers or marketing manager can make decisions. as we go further, then we can see there may be some KPIs, there's some reports, and you can see that sort of BI, and pyramid there. And for us, we want to specialize more advanced analytics here. Mainly is predictive of customer behavior, and recommendations and customer lifetime value. And so some of the projects that are not captured by SQL or those Tableau reports, and we want to answer those questions that there's no obvious answer. It's not a programming, it's not a SQL, but it's need a little bit thinking. You need assumptions, you need models, you need to explore the data, you need to see what data can you get and what answer can you have. But in terms of productionized is email personalization, using a long array of models, and that's where we started working with H2O. And we also have site recommendation, and which is real time if customer goes to the site and they browse products or they try to check out, and will recommend additional products that might be interested, similar to other e-commerce vendors. And we also answer questions from senior management if there's something that's not easy to answer, and then we'll try to explore.
Play Sherlock Holmes with data.
Yes, yes. Mm-hmm.
So you're doing recommendations. I'm pretty sure Brooks has some bit of good sensor data that you're going to talk about. Most of these talks are there, so not necessarily have to be H2O-centric. But what would the world's, Macy's has a really impressive recommendation problem, right? Because it has a vast array of products, vast array of stores and demographics and regions. And we happen to have one of the top recommendation engine experts sitting next to us.
Yeah.
So what would the world's most problem person ask the most solvable solution offering person, Rex's person? What would you ask him if you had to?
There were lots of questions, of course, and for us, we are on a journey of test and learn. But certainly, how can we increase the coverage? Because there are only a small portion of a customer that we really know a lot, and a lot of customers we don't know much, and how to make relevance important to them, and certainly would be a very important topic. Some people call them cold starting, and
cold start would be the question I would have
exactly, and so that would be one of the top.
So I was having a conversation over lunch with somebody, and I actually I proposed a solution for his problem. And I told him, here's a proposal for you. Go back and implement this, and we'll split the gains once you tell me if it worked or not. So that's always my default answer when somebody asks me, like, and I don't know anything even about the data or the domain. There's always two basic steps that you need to do to build a recommendation engine. One is sort of like fight the sparsity in your data set, which is exactly what you're saying. And the other one, which is really figuring out how do you integrate collaborative filtering with everything else. And the everything else makes a lot of, it's very important, especially for cold starting and other situations where you don't really have that data. And the good news is that has been solved, and really, to attack collaborative filtering problem and also sparsity issues, approaches like matrix factorization, which there are a ton of them, and you can go into factorization machines and things like that, are really good. And then to integrate that with anything else, all you need, somebody said their favorite model, you said it was an ensemble, right? So all you need to do is just feed that into an ensemble. You can use a gradient boosted decision tree, and then let the tree figure out if new users are going to use more of this feature or more of this other feature or less of this other one. So I think that's a very typical approach, and it gets you 90% of the way there, if not more. And the good news is, even if you're going to go into deep learning and feed other fancier models into it, you just feed it into the ensemble and let it figure out, like, what's better. So I think that's a very simple answer, but I think it works 90% of the time.
Yeah, I've seen, I mean, actually, vectorization machines and actually matrix vectorization is part of the H2O roadmap, partly because of that emergence of it.
Yeah, actually, sorry to interrupt, but vectorization machines is a step further because it actually integrates matrix vectorization and polynomial regression into a single model. So you kind of like got everything in once. But still, feeding that into an ensemble is always a good idea. So, yeah.
Yep.
What about choice models? Do you happen to, I mean, typically some of the questions that come up from likes of Nahum are, I know that your GBM is able to get all the mean square error, it gets the entire population, and forgets to get, I mean, it gets my most valuable customers, or forgets to get the 99 percentile or 85 percentile and above customers.
Yeah, so this is something that I struggle with a project that I mentioned in my talks, that you have a very unbalanced data set. And what I really care is about this little set. I don't care that much about the others, but GBM by definition minimize the overall mean square error.
Yeah.
So all the square error minimizes it. And so the way I dealt with this is by subsampling, by doing multiple versions and ensemble and trying multiple copies and things of that sort. I had to go to that needle in the haystack. And so we did get a really good improvement relative to that. And just one comment relative to the ROC curve. Everybody shows the ROC curve, and this is where you look, compare it to the straight line, which is the random. But I think this should be improved because nobody is flipping coin there. You need to do it for uninitiated person who know the problem, try to come up with some intuitive rules, how you improve upon those. This is the true test.
I just want to highlight, because I think something that you mentioned is very important, because I face this all the time. People in general and data scientists are obsessed with using all the data they have, and sometimes subsampling is a great idea to do. And it's sort of like, not even that, it's actually biasing your training data set to whatever you want the model to learn.
Right.
It's a good idea. So it's like, it's not bad, and you don't need to hide yourself from like, hey, I threw away half of my negative samples because maybe they're biasing the model in the wrong way, or because you want to weight your model more towards some particular users or some data points. I think that's something that people don't understand enough, and they try to sort of like be democratic about like, oh, I need to use all the data and it all needs to count the same. Well, maybe that doesn't align with your business objective, right?
I think it depends on the data as well. I mean, if you have a class imbalance problem where your event is very rare, right? You get to use the data size enough to get that event, right? So it also depends on the data. The point is.
Yeah.
Yep.
Balancing the data. I'm sorry.
You guys have used other techniques to fight unbalanced data sets as well.
Well, I think we requested point weights in one of your JIRAs. So yeah, I think there
has been implemented, right, Arno?
Yeah, where is that, Arno? Is it finished?
Yes.
Okay. But yeah, I think one of the problems with a lot of these models is they're pattern recognizers, and if you don't have any of that market share, well, there's no pattern to recognize in the segment of business that you don't have any of. So yeah, I think it's probably a area that people don't pay enough attention to is, well, this is the sample of data that I have, but I most certainly have some censoring and truncation biases. So, how do you cope with those? And I think that there's some obvious techniques, but you have to be clever.
There is a struggle there. I mean, subsampling, I have less problems with explaining than supersampling. That is, you create data. What is this data? Just artificial data, which is harder to explain than that. But at the end of the day, I think more important than explanation is, does it deliver what you need to deliver? Do the people who need to use it, and it gives them the results? Then who cares?
So the problems that you solve are usually one with bias versus variance, right? You try to fight bias and variance in your data. What are your typical techniques that you've applied on this?
At Macy's?
Yeah.
Yes. We try to, we have a lot of products, so we try to, that's why we need to scale our modeling platform, be able to handle, the large amount of data, the recency, frequency, monitoring in all dimensions. And we find that if we include more features and our models and accuracy improve. And another thing actually we found is it's very important that no matter what, some models are more accurate than the others. And a lot of time, one customer is score high in one category, score high probably in many other categories. And how do you make decisions given the fact that the model accuracies are different and the prior distributions are different? And that's something that we are also trying hard to balance, basically. Tomorrow, I'm going to talk a little bit about some of that.
What are some interesting things you found? I mean, we have the kind of the insurance, retail, and health. Are there interesting things that cross-pollinate, that grows between different verticals? I was going to ask you a question around what are things you found in, for example, weather data. The way you use weather data is probably different from the way retail uses weather data.
Yeah, so I don't know how much I can talk about specific applications. I think Pavan, who's our big data business leader, will be talking tomorrow, and invite you to attend his talk. But yeah, I think there's definitely a lot of things that cross different areas of your organization. And I think that's where a lot of big data can help you a lot, is to expose learnings that you have in one area or organization and cross-pollinate that to other areas. Even in data management, where, whereas previously you might have had a silo of data, that's now exposed to a much larger group.
Mm-hmm. In terms of overfitting, do you run into that often, and what are typical remedies that you've applied in that?
Well, I mean, yeah, that's one of the main issues that any machine learning practitioner will run into, right? So obviously the biggest tool for that is regularization. So you need to learn and understand what that means and how you can set your priors right and use your regularization in whatever model you're setting up. So for example, I see people running a validation on a GBM and just taking whatever hyperparameters come out of the GBM, and my question is always the same. It's like, I mean, have you looked at the number of leaves that your GBM has, how many trees you have, how many features or variables are you inputting into that model? Are you sure that's not overfitting? Because people will just run a grid search or even a Gaussian process Bayesian optimization method and just take whatever comes out of that as, okay, this is the optimal, but the optimal can actually be overfitting. And understanding sort of like what are the meaning of the parameters that your model actually pick, I think it's an important one. It's an important thing.
Yeah, I mean, even for us, I mean, understanding the parameters is very important, especially when it's very close. I mean, it's healthcare, so understanding each parameter. We go down a very rigorous process on that. We do for parameter exploration. We understand each and every parameter. We go for understanding how the characteristics review is done, what's the impact of it. We take use cases and get physicians and clinicians who are subject matter experts involved in the process, because I come from ad tech, so if I miss an ad or miss a customer, it's fine. But if we do mistakes which can impact life, it's humongous. So we go through a lot of validation there.
Yeah, overfitting for us, definitely we definitely use a lot more out of samples, testing, and we evaluated models, not sometimes even regularly actually is not even at the same time period. And then you guarantee that whatever you learn, is going to be valid. And for us, it also there are lots of tests and experimentation. It means that we'll have different models or something. The ultimate test actually is to make your decisions and see how that produce results. And there could be things happening that maybe you can't explain, but as long as it works, we're practical, we're practitioners, and as long as it works, it will just fine for us.
One particular kind of overfitting that I think people don't pay enough attention to is sort of like temporal overfitting, which basically means that your model works today, but it won't work tomorrow. And that's a long discussion, but I think a model retraining and understanding your parameter space well and how you're tuning it is also important. And also limiting the complexity of your model to just what is needed, right? Not adding extra features that are not really adding anything, but you just look good because you're saying, oh, my model has 2,000 features. Who cares if it's only really 300, right?
Outcomes, Razor.
Yeah.
Yeah, I would say in more of an industrial setting, information leakage is a bigger problem than on a Kaggle data set where, I think that's the part that really is missed in a lot of the predictive modeling competitions is you're dealing with a very different environment when you're actually going to put a model into production where, the underlying data might change over time. And I think, a lot of databases don't have a timestamp on every field. So did you really know about that, feature at that, point in time when you're making that decision? I think those things need to be a lot more practically.
What about regulation? I mean, regulatory aspects can stop in some of the businesses, especially in your case.
Some of the regulation requires that the decisions of the model need to be explicit. So unfortunately, this will require you to use models that may not be as efficient as the best algorithm that you can. Let's say you use a decision tree, which is not as good as random forest or as GBM, but if they want to know exactly what led to the decision, what are the rules that led to the decision, that's about it. I mean, they won't get, I put a black box and I put this in there, or these are the variables with the strongest influence, which is what those black boxes will deliver. Sometimes this regulation applies, and I'm not sure applies to everything, but it used to apply to credit, for example. If you approve, PayPal doesn't give mortgages, but I know in the mortgage field, you have to explain exactly why you refuse to give someone a loan, etc. But PayPal is also, of course, has PayPal credit, so we provide also credit, and this is some of the model that we need, and the regulation, whatever the regulator wants, you have to go with it all over. It's not just a single one, all over the world when you need it if you go international.
I think that's actually a really interesting question. I don't know if you've seen this talk that Max Kuhn, the author of the Carrot package for R, gave, but he talked about an example where he was developing a diagnostics device that would detect, I think, a particular type of bacteria. And lo and behold, he found himself in the hospital with his kid, and his kid had sepsis. And he then said, well, I wonder which machine they're using, because he recalled an interesting encounter with regulators where they basically said, we want you to use logistic regression because we don't understand this more complex model. And it was a profound drop in accuracy to go to a logistic regression. And he found out that the diagnostics device was one of their competitors. And he wondered, did they back off and use logistic regression and instead of fighting, to go with the model that's the most accurate? And well, his kid was diagnosed properly, but I think there's almost, in the healthcare industry, it's almost a matter of ethics. And I think that was an interesting revelatory moment for me. Like, if your kid was being diagnosed with this, would you want a logistic regression, or would you want a more accurate model?
That's certainly a tweetable
Yep.
one. Your talk is actually titled "Saving Lives with
Right.
Data Science."
Yeah.
Tell us a little about what that means.
So-
how can you propose deep learning or gradient boosting method being used to save lives versus?
Right. It's a very good question. So, I mean, at the end of the day, when physicians are evaluating it, you've built a model does well, you think you have a candidate model that does really well. You have go through this rigorous process of evaluating that model. You have to answer the physician's questions in terms of, okay, you think this feature is one of the high predictors, and why is this high predictor? Then you drill down and explain him that, okay, this feature is maybe, for example, say a log of something that I'm using, or a combination of these things, which actually drills down to these particular things, which they can take it to research and then correlate it with something that is impacting health. So that becomes a very, very important step. And that's one of the things why, for us, to take something into production is hard. It takes, and there is a very good reason for it. We don't want to be wrong, basically, and that's the goal of it. So as you know, we were discussing about ways to make it simpler, make it faster, but at the same time, we want high accuracy. We don't want to miss anyone. We want to get every last patient who's there, to save them ahead in time. So for us, that rigorous process, taking time in months, is very fruitful, and will help to backtrend the actual value of them.
How long does it take for a model to get to production, typically in your organizations?
I think it really depends on what it's being used for. There's all sorts of different model deployments. So some of them are internal. My group tends to focus on things that are a little bit more, I would call them like decision support tools, rather than things that are production facing on a web page. But it can vary a lot depending on where you are.
It's days, is it weeks, or months? Or
I would say it's in the months range.
years?
In ours, it varies, and I would say typically is weeks and possibly months. But what we try to, when we productionize, it means that it will be scored, regularly and automatically picked up by the targeting or decisioning tools, and so that there's that aspect. We're hoping that Poju will help us and dramatically shorten that, turnaround time. And
so for us, definitely months and months. But I mean, the goal is different. We are not a
Safety.
retail. Yeah, safety and accuracy is important.
I think in our
Hourly, right? Seconds.
our second. I mean, it really depends on what the constraints are on the performance and the scalability of the particular model. If it's a model that can be scored offline and we don't really care if it takes sort of like seconds, getting into production is going to be hours, right? Like you can change it all the time and nobody cares, and it's okay if it's a little bit slower or if it performs a little bit worse in terms of speed and so on. So you can be much more flexible there. However, if you have a real-time sort of like needs to be taking real-time features and need to respond quickly and fast, that tweaking usually requires more in the order of weeks to get it there, because otherwise you might be improving the accuracy, but if you're hurting the speed of the page when it's loading, you're going to be losing the A/B test anyway. So you need to get it to a certain level of production.
And from my point of view, there are two types of this. part to take production is to get the agreement of the business. Is this the right thing to do, or this model the right model and the right implementation to deliver the result that they expect, or the uplift. Everybody wants to see an uplift or something. This is one thing. This may take, it depends, and just as it says, it depends on the process, how critical the process is. On the other hand, to take the technicalities of taking software to production, hardening from proof of concept to production, this takes much shorter time, either if you do it in pure Python, or very soon if you use your Python in H2O, converting to Pojo, get a jar, here you go, take a jar, include it in your software. So those are the technicalities, and those will take faster. Those take faster. It's the evaluation and making, and someone says, yes, I'm going to bet my reputation or my career or whatever on this model, this sometimes takes longer.
Quick round of another questions on cloud, not cloud. How much are on cloud versus
Define cloud.
on-prem? Define
What
cloud.
is cloud? Internal cloud, external cloud, what is cloud?
External cloud, then public cloud, then private cloud, internal.
We are only private cloud. We take very seriously the privacy and the control of our data. So we don't let data cross the firewall. So if it's on a cloud, it's on our cloud, and we have very good private cloud, very dynamic private cloud, etc. But then again, this is paper.
Yeah, we're in AWS.
AWS.
Yeah.
On-prem.
We have our own servers, yes. Again, privacy is the main concern. We don't want to compromise in any way. So we work vendors. A lot of time, those data would be some way protected, which means less data, basically.
We've done some proof of concepts with AWS, but we're very conscientious as well, being a financial services company, of data protection standards. So we're moving cautiously.
There's some time left for audience questions. So if there are any questions, please.
Very little time left, maybe one question. That's what it is.
There's a couple of hands.
Can you elaborate a little bit on what are you doing in case you have seasonality in your data, or non-stationarity? How do you deal with the lifetime of data? Roughly, is it automated? You sort of repeat the models, or do you have some automated ways of doing it?
Seasonality, probably.
Seasonality, I mean, whenever you are in e-tail, as in PayPal and its merchant, etc., it's very strong seasonality. That's why you need enough data. This is part of the big data to smooth over, or to take into, to see those seasons in the data. So sometimes it might force you to use 2.5 years of data just to look at the holiday season and things of that sort. Yeah, seasonality is definitely in the game.
Yeah, go ahead.
Oh, sorry. I was going to say, I think it's a combination of two things. One is how big of data or window you're feeding into the model, and the other one is how often you retrain it, right? Because you can take the opposite direction, which is like, I don't need to take a lot of seasonality into account because I'll be just retraining my model from zero every week, so to speak. And then you're basically trying to fit the model into a small, I think you need to combine both approaches in some way, because there's a lot to learn about the long time frame, but both combination of retraining and sort of like data size, and it's probably the right answer.
Yeah, I would say, if we use data that are too long, and you lose relevance. Mm-hmm. If you train the data with too small, too short a time, you include a lot of noise. So it's really a balance of that thing. I don't think there's a strict rule, and you have to use your domain knowledge And for us, holiday season was non-holiday seasons, seasonality, those are going to be very, very important. You could include some of the effects using indicator variables. You could also use that to retrain your model more frequently. That's why, again, we are looking for more responsive, fast turnaround platform for model building.
One last question.
Thank you. So I want to ask a Monte Carlo prop here. Sorry. I want to ask a Monte Carlo method. So we know that a Monte Carlo method is very computational complicated, expensive, and I want to know what kind of tools are using for big data to using the Monte Carlo method, and also can you give me an example about your experience about using Monte Carlo method in business?
Can someone repeat the
Can-
question?
yeah.
Repeat it.
Can you repeat the question?
Can you repeat the
I
question?
think it was to do with Monte Carlo methods.
Monte Carlo.
Yeah, so Monte Carlo method in business, and what kind of big data tool for that?
For Monte Carlo? Yeah. I mean, sometimes we, for example, site recommendation, if we want to, take into account errors, if we want to improve freshness,
Right.
and sometimes we add a little Monte Carlo sampling there and to explore a little bit the space, and we could in the future and using Monte Carlo to do optimizations and to explore the possible parameter space and what tool we use. I think again there's so many tools possible and even SAS, now you can do MCMC, and so, yeah, I think the important are the concepts, and how do you solve problems. I would say tools are becoming less and less important. I don't know other people.
No, I think you 100% agree. I mean, part of my grad school work was in cellular Monte Carlo simulations. That time I had written everything in C, and I'm dating myself back in like 10, 15 years back. Now it's out of the box. I mean, I don't have to write a C program to do anything right now. I can use R and Python very well, and packages are there that can do that job of Monte Carlo simulations.
Thank you. A warm round of applause for our amazing panel.